Hello, welcome to my class. In the last video, we discussed exercise 1.1 from the chapter Real Numbers. In this video, we are going to discuss exercise 1.2 from the chapter Real Numbers. And if you have not subscribed to my channel, please subscribe and do like the video if you like my class and share it with your friends. Do not forget to click the bell icon to get notifications also. If you have any doubts, you can ask that as comments, okay? And the purpose of this channel is to make you understand the concepts of maths very clearly. In maths, it is very important to understand the concepts, right? So, I'll try to make you understand all the concepts very clearly. Okay, so with that said, let's get started. And the first question is, write these numbers or express these numbers as a product of its prime factors. So, we can just prime factorize this and we'll get 70, 35, 5, 7. So we can write this as 2 square into 5 into 7. So 140 is equal to 2 square into 5 into 7. Now 156, 2 is a factor, then 78, 2, 39, 3 is a factor, 13. So 2 square, 156 is equal to 2 square into 3 into 13. Now 3825. Is 2 a factor of this? No. Then is 3 a factor? 8 plus 2 is 10. 10 plus 3, 13. 13 plus 5 is 18. So, 3 is a factor because 18 is divisible by 3. So, 3 we can divide by 3 and we will get 5. Then is 3 a factor again? 7 plus 5 is 12. 12 plus 2, 14. 14 plus 1, 15. So, 3 is a factor. 425. Then 6 plus 5 is 11. 3 is not a factor. Now, is 5 a factor? Yes. So, 85. Then 5 is again a factor. 17. So, this is a prime number. So, it cannot have any other factor. So, 3825 can be written as 3 square into 5 square into 17. Okay. Now, 5005. What is the first factor of 5005? It is 5. So, we will get 1001. Now, 7 is a factor of this. If we divide 10 by 7, we will get 1. Then 30. 30 by 7. 7 fours are 28. 2 remainder. Then 21 by 7 is 3. Now, is 7 a factor of this? No. The next prime factor is 11. So, we can check if 11 is a factor. Yes, 11 is a factor because 14 by 11 is 1. 3 remainder. 33 by 11 is 3. So, this is also a prime number. So, we cannot proceed. Which means 5005 is equal to 5 into 7 into 11 into 13. Okay. Now, 7429. We can factorize this as, is 2 a factor? No. Is 3 a factor? 7 plus 1 is 11. 11 plus 2, 13. 13 plus 9 is 22. 3 is not a factor. Is 5 a factor? Obviously no. Then 6 is not a prime number. 7 is a prime number. Is 7 a factor? No, because 7 divided by 7, 1, then 0. Then 42 divided by 7 is 6. Then 9. 9 divided by 7, you will get 2 as remainder. So, 7 is not a factor. Then 8 is not a prime number. 9 not a prime number. 10. Then 11. Is 11 a factor? No. Because 74 divided by 11 is 66. Then 8 remainder. Then 77. Then 5 remainder. 59. You will get this as 59. It is not divisible by 11. So, this is not divisible by 11. Then is 13 a factor? 13 is also not a factor. Then 15 is not, then 15 is not a prime number. 16, 17. 17, we can see whether 17 is a factor. 17 into 5 is 85. So 17 into 4 is 68. 17 into 4 is 68. So 6 remainder. Then 17 into 3 is 51. Then 11 remainder. 109 divided by 17. 17 into 7 is 100 and that is 119 divided by 17. We will get 17 into 7 as 119. So 17 is a factor. Now we will check whether 17 is a factor of this. 17 into 2 is 34. So 34, you will get 9. 97. 17 into 5 is 85. Then 85 plus 17 is not 97, right? So the 17 is not a factor. Now we will check if 19 is a factor. 19 into 23 is 19 into 23 is 437. So what are the factors, prime factors of this? We can write 7429 as 17 into 19 into 23. Okay, understood? You can pause the video, write this and proceed to the next question. Okay. Next question is find the LCM and HCF of these numbers and check whether LCM into HCF is equal to product of the numbers. So, LCM of 26 and 91. We can factorize this and we'll get 2 and 13. And when we factorize this, we'll get 7, then 13. Okay, so what is the HCF? It is 13. That is common factor. Highest common factor is equal to 13. And what is the LCM? LCM is equal to 2 into 7 into 13, which is equal to 14 into 13, and it is equal to 182. This is the LCM. Now we can verify whether HCF into LCM is equal to product of the numbers. 91 into 26 is 6 9s are 54, 182. So we will get 2366. And what is LCM into HCF? 182 into 13. So we will get this as 2366 again. So LCM into HCF is equal to product of the numbers. Okay. LCM and HCF of 5, 10 and 92. So we can factorize this. We will get 2, then 2, 5, 5. So 5 is a factor. We will get 51. Then 3 is a factor. We will get 17. So this is equal to 2 into 5 into 3 into 17. And 92 can be factorized as 2, then 46, 2, 23. Right? So this can be written as 2 into, we can write this as 2 square into 23. So what is the LCM? LCM is the, we have to take the highest number of prime factors. That is, here we can take 2 square and 3 is there, then 5 is there, then 17 is there and 23 is there. Right? And 4 into 5 is 20. 20 into 3 is 60. So this is 60. Now 60 into 17 into 23. 23 into 17. 391. 391. Now 391 into 60. 6 into 1, 6. 6 9s are 54. 5 carry. 6 3s are 18. 18 plus 5 is 23. Then 0. So LCM of this is 23460. And what is the HCF? The common factor. What is common in this? 1, 2 is only, here only 1, 2 is there, and here also 2 2s are there. So 1, 2 from this and 1, 2 from this is common, which means HCF is equal to 2. Okay, now we have to verify whether LCM into HCF is equal to product of the numbers. What is LCM into HCF? 23460 into 2, which is equal to 46920. Now what is product of the numbers? We can multiply 51 by 92 and add a 0. So we will get 102, then 945. So 4692, then 510. It is 510. So we have to add a 0. 46920, 46920. So we have verified that LCM into HCF is equal to product of these numbers. Okay. Next one, 336 and 54. So factorizing this, we'll get 2 is a factor. 1, 6, 8. Then 2 factor, 84. 2, 42. 2, 21. 3, 7. And 54, 2 is a factor. 27. 3 factor, 9. 3, 3. So we can write this as 2 raised to 4 into 3 into 7, and this is 2 into 3 cube. Okay, so what is the LCM? LCM, we have to take the highest number of times it is occurring. So 2 raised to 4 into 3 cube into 7. Right? So this is equal to 2 raised to 4 is 16. 16 into 27 into 7. 27 into 7 is 189, right? 7 sevens are 49, 4 carry, 2 into 4, 14 plus 4 is 118. So 189 and into 16. So 6 nines are 54, 6 eights are 48, 53, 1, 1, then 189. It is 3024. So LCM is 3024. Okay. Now what is the HCF? What is the common factor? Highest common factor in this? 2 is common. Then 1, 3 is common. So highest common factor is 2 into 3, which is equal to 6. Now we have to verify whether LCM into HCF is equal to product of the numbers. What is LCM into HCF? 3024 into 6. 4 6 are 24. 2 6 are 12. 12 plus 2 14. 1 18144. And 336 into 54 is 24. 14. Then 13. 30. 18. 16, 18144, which is the same as this. So we have verified that LCM into HCF is equal to product of these numbers. Okay. Next one, find the LCM and HCF of the following numbers by prime factorization method. That is the question, and in that first part is find the LCM and HCF of these numbers 12, 15 and 21. So prime factorization. First we can factorize 12. We will get 12 is equal to 2 square into 3. Okay. Now 15. 5 is, we can write it, 3 is a factor, then 5. So we can write it as 3 into 5. Now 21, 3, 7. So 21 is equal to 3 into 7. So what is the LCM? LCM is equal to 2 square into 3 into 5 into 7, which is equal to 4 into 3 is, we can write 4 into 5 is 20. 20 into 3 into 7, that is 60 into 7. What is 60 into 7? It is 420. 6 into 7 is 42. Then add a 0. So we will get it as 420. And what is the HCF? What is the factor here? Common factor. 3 is a factor of this, 3 is a factor of this, and 3 is a factor of this, which means HCF is equal to 3. Okay. Next one, find the LCM and HCF of these numbers. 17 is a prime factor, 23 is a prime factor, 29 is a prime factor. So there are no common factors, which means highest common factor is 1. That is, they have no common factors other than 1. So highest common factor is equal to 1. And what is the LCM? We have to multiply this. 17 into 23 into 29. 23 into 29 is 3 nines are 27, 18 plus 2 20, then 6 4. So 667 into 17. 7 sevens are 49, then 42 plus 4 is 46, 42 plus 4 is 46 again. Then 667, so sorry, we have to 667, so we'll get this as 11339. So LCM is 11339 and HCF is 1. Okay. Next one, find the LCM and HCF of these numbers. 8 can be written as 2 cube. 9 can be written as 3 square. 25 can be written as 5 square. So what is the HCF? There is no factor other than 1 which is common to all these numbers, which means HCF equal to 1. And what is LCM? LCM is equal to 8 into 9 into 25. And what is 25 into 8? 25 into 8 is 25 into 4 is 100. So 25 into 8 will be 200. 200 into 9, which is 1. 200 into 9 means 2 into 8, 9 is 18. Then 0, 0. So 1800 is the LCM of these numbers. Okay. Understood? Now we will proceed to the next question, that is fourth question. Okay. Next one, if HCF of 306 and 657 equal to 9, find LCM of 306 and 657. We know that LCM into HCF is equal to product of the numbers. So we don't know LCM. We have to find the LCM, and given that HCF is 9, so we can write LCM as X. X into 9 is equal to product of the numbers is 306 into 657. Don't find that product, leave it as it is, and X equal to 306 into 657 by 9, right? And 9 will go in this. 3 nines are 27, 3 carry, 4 nines are 36. So 657 into 34. 657 into 34 is 7 fours are 28, 22, 26, then 21, 17, 19. So we'll get 2, 2, 2, 2, 3, 3, 8. So LCM of these numbers is 22,338. Okay. Check whether 6 raised to n can end with the digit 0 for any natural number n. Can it end with digit 0? No, right? So we can explain, like for any number to end with digit 0, it should have 5 as a factor. But the factors of 6 are 2 and 3. So 6 raised to n can only be written as 2 into 3 the whole raised to n, and by the fundamental theorem of arithmetic, it guarantees that 6 raised to n cannot have any other factor than 2 and 3. So 5 is not a factor of 6 raised to n. So 6 raised to n cannot end with digit 0. Copy this and proceed to the next question. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So to do this, we can first write 7 into 11 into 13 plus 13 is equal to 13 is common in both these. So we can take it as 13 into 7 into 11 plus 1. Right? So this is equal to 13 into 77 plus 1, which is equal to 13 into 78. So we can factorize 78 and write 78 is equal to, so we can write it as 13 into 2 into 3 into 13. So there are more than one factor in this, that is 2, 3 and 13 are the factors, which means this is a composite number. Now we can write this 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 as 5 can be taken out. Then 7 into 6 42, 42 into 4 is 168, 168 into 6. 168 into 6 is 6 8s are 48, then 36 plus 4 40, 1008. 5 into 1008 plus 1, which is equal to 5 into 1009. 1009 is a prime factor. So this 5 and 1009 are the prime factors of this, which means this is having more than 2 prime factors, and that means this is a composite number. Okay, so we can say these two numbers are having more than one prime factor, which means this is a composite number. Okay. Next one, there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet at this starting point? So there is a circular path and Sonia takes 18 minutes. Ravi takes 12 minutes to get to the starting point. After starting from the starting point, they will reach the starting point in 18 minutes and 12 minutes respectively. So after how many minutes? So the question is, after how many minutes will they meet at this starting point? So we have to find the LCM, right? So LCM of 12 and 18. So 12 can be written as 2 into 2 into 3 and 18 can be written as 2 into 3 into 3. So what is the LCM? This is 2 square into 3 and this is 2 into 3 square. So what is the LCM? LCM is equal to 2 square into 3 square, which is equal to 4 into 9 and that is equal to 36. So they will meet at the starting point after 36 minutes. Okay, so with this I am winding up this video because we have finished exercise 1.2 from this chapter, and please don't forget to like, share and subscribe so that others can also benefit, and share to as many friends as possible so that they can also benefit by watching this video. Okay, thank you and bye.